So this week we're learning about double replacement reactions, which are where two ionic compounds react to presumably form two new ionic compounds, where everything still has its same functional charge. We're just switching cations and anions. We're also getting into learning how to predict whether a reaction of two aqueous solutions might produce an insoluble precipitate. So we're going to take a look at an example today where we take a couple of test tubes with some sodium phosphate solution, and we're going to react it, each one with another ionic compound, and predict what happens. So as we've been learning in that solubility chart that we've started looking at this week, there are certain types of tips that we can tell if it is predictive of a high likelihood that that ionic compound will form a precipitate or not when it's formed in an aqueous environment. For example, high solubility compounds tend to have alkali metals like sodium and potassium in particular, but also could have, like, say, lithium. Chloride compounds, most of them tend to form pretty soluble solutions, and nitrate-based compounds tend to be quite soluble, all in all. On the other hand, there are many types of compounds that are likely to have a fairly low to no soluble character, such as compounds that have heavy metals like mercury, lead, silver, phosphate-based compounds, hydroxide compounds, carbonates, sulfides, oxides, and others. So we can have a pretty decent idea whether there's a good chance that our products will have an aqueous state or form an insoluble precipitate. So first of all, we're going to take a look at what we predict will happen when sodium phosphate and potassium chloride combine. I've already gone ahead and predicted the products and balanced it. We can see that we have a predicted potassium phosphate and sodium chloride as the products. I put AQ for aqueous because sodium chloride has a highly soluble alkali metal and a highly soluble chloride ion. So we say pretty likely we'll have a soluble aqueous solution. On the other hand, it's not quite sure about the potassium phosphate. Certainly, many potassium compounds tend to be very soluble, but phosphates tend to be fairly insoluble. So we're going to find out if we have a soluble or insoluble compound here. We will also look at sodium phosphate combining with lead nitrate, which we predict will produce lead phosphate and sodium nitrate. According to the solubility rules, we can say that pretty high likelihood there is that sodium nitrate will be aqueous. As a matter of fact, sodium nitrate is one of the most soluble compounds in all the pantheon of hundreds of ionic compounds that are out there. On the other hand, lead phosphate has two classically insoluble ions, a lead cation and a phosphate anion. So I'm going to predict that we'll have more likely an insoluble solid. Let's find out what happens. So we'll first start off with taking some of our potassium chloride here and see what happens as a result. We had a substantial amount. I stir around. I can't see any evidence of any precipitates forming at all in this particular case. So we can say that this was definitely a case of two aqueous compounds floating around. In some respects, you could say there was not really truly a reaction that took place. We're just simply having a series of aqueous ions, chlorides, phosphates, potassiums, and sodiums floating around and not truly reacting to any extent that we see here. Now we move on to where we have the predicted precipitate forming. We predict that in this case, when we add this sodium nitrate, that we will get some insoluble sodium phosphate. Let's see if a precipitate forms. Indeed, it certainly does. This is very thick, completely opaque product here, and there are no surprises. We have two classically insoluble ions here. Since neither one of them tends to be soluble, we were pretty safe in our assumptions here. So, in conclusion, not all cases where ionic compounds combine will you visibly see a reaction take place. That's because there is all the ions in question are highly soluble, and so there will not be some affinity for an insoluble product to be formed. On the other hand, some compounds, when produced in a reaction, will be highly insoluble.